Good morning, everybody. Good morning, good morning. Who is he seeing, everybody? Let me just close off everything I have open here. How is everyone doing this morning? Alright, so we didn't see each other in a little while. It's been a quick minute, but I mean Saturdays, it'll be everybody has something to do on a Saturday, but as long as I am available, I do. If it is not available, I will make the asynchronous classes to upload it. So how school going for everybody so far? I hope everybody having a good time at school. School going good? School was good in a way. Alright. Well, let me see what we could do today now. Today what I want to do with all you, I want to jump into solving equations. Because we don't look up fractions already, right? We look up the fractions. And we look up algebraic fractions and in the last class we had. Right, so all these things look up. So I want to go over them notes. Real important notes to go over, right? Any news about lower six going into school now? Well, yeah, lower six part of going school when all you get accepted into whatever school all you apply to. Alright, the school will let all you know when all you had to come in. So this morning I want to go into a little thing called solving equations, right? Basic equations. And it's something that has given plenty students a little bit of trouble. So let me start something. Now, if I ask everybody here, right? What is x if 2x is equal to 4? Most people will come and say, well, x could be equal to 2 because 2 by 2 is 4. So x can only have one value of 2. But how we get 2? We do something to get 2. So we're gonna list some steps into solving an equation where you can solve any linear equation. Right? So solving linear equations. Now I want you all to take this very, put it as a note in all the book when all taking on the notes, right? Solving an equation is the same thing as making something the subject of the formula. It's the same thing as transpose x or transpose y. All of these different ways I can ask a question, I can say solve the equation. Alright? So let's see how we're going to solve our equation. So the first step, first things first, let me define what a linear equation is. So a linear equation is any equation, and an equation have an equal sign. So a linear equation is an equation where the highest power of the variable is 1. So for example, 2x plus 3 is equal to 4. That is a linear. 4x plus 9 is equal to 11. That is our next linear. 2 plus 3x is equal to 16. That is a linear. As soon as I have a x squared or a y squared or a z squared or something that is not to the power of 1 in my equation, well, brother, that is not a linear. So right now we're dealing with linear equations where all the powers of the variables are 1. So as I list that step, I'll do the example for that step. So 1. First, we rearrange the equation by bringing or moving. Tell me if the text is too small for you, right? I'll zoom in a little bit. By bringing or moving all the variables on the left hand side and all other terms on the right hand side. Now, good lord. Moving all the variables, I'm gonna put in something here, all the variables we are solving for. So if the question says solve for x, I'll bring all my x variables on the left hand side. If I say solve for y, I'll bring all my y variables on the left hand side. If I say solve for z, I'll bring all my z variables on the left hand side, and I'll carry everything else on the right hand side. So let me do an example here. So the example, let me say we have to solve for x in the equation 2x plus 3 is equal to, let me put 2x, let me put 14x plus 3 is equal to 9x minus plus 18. Alright? So the first step says, here was the C. Bring all of my variables I'm solving for on the left hand side. Well, in this particular case, I am solving for x. I already have 14x on the left. So the 9x, I want him to also be on the left. Now this is a rule everybody should know. Whenever I move a term across an equal sign, the sign in front of the term changes. So I'll move the 9x across, and I'll also move the plus 3x across. So when I rearrange, I get 14x minus 9x is equal to 18 take away 3. Step 2, I will simplify both sides. Now when I simplify both sides, I'm actually just going to add them up, take them away, multiply them, divide them, whatever operation I have there. In this case, it's very, very simple. 14x take away 9x. I have 14 of something on one side, and I have to take away 9 of something. So 14 take away 9 is 5x. Is equal to 18 minus 3 is 15. Alright. Step 3. I will divide by the coefficient of x. Well, not of x, of the variable. On both sides. Well, when I divide by the coefficient of the variable on both sides, first, what is a coefficient? Just think of coefficient being the number in front of. Alright? Coefficient is the number in front of. So the number in front of the variable is 5. So I'll actually put down the operation of dividing by 5 on both sides. 5x over 5 is 15 over 5. The 5 cancels with the 5. 5 cancels with the 15 to give me 3. And I get x is equal to 3. 3 very, very simple steps. Once I follow these 3 simple steps, I can solve any linear equation I come across. Any linear equation. Let me do an example now without putting in any steps. So for example, let me solve for x in the equation. 14 into x plus 2 is equal to 3x minus 5 plus 2 into x minus 1. Well, the first step states I need to rearrange this equation. But I cannot rearrange it as yet. By rearranging an equation, I need to have individual terms. Well, easiest thing to do, let me expand the brackets. If I expand the brackets here, whatever is outside is being multiplied by everything inside. So the 14 is being multiplied by the x, then I'm multiplying 14 by the 2. So I put in the symbols here. 14 is multiplied by x, and then I'm multiplying it by 2. So I'll get 14x plus 28 is equal to, the 3x remains by lonesome, 5 remains by his lonesome. I have now positive 2 by x, that's positive 2x, and positive 2 by minus 1 is minus 2. Now, I can rearrange. Well, I go have 14x, I'm moving the 3x, it becomes minus 3x, I'm moving the 2x, it becomes minus 2x, is equal to minus 5 I move, minus 2 I move, and I'm moving the 28 and I'm bringing it across on the right hand side. So from plus 28, he goes to minus 28. Well, 14 minus 3 is 11. 11 minus 2 is 9. So I get 9x on this side. Minus 5 minus 2 is minus 7. Minus 7 minus 28 is minus 35. And while on this topic of negative numbers, on a scale of 1 to 10, how good are you guys with negative numbers? Like adding this side here. 10 being the best, 0 being I can't do it at all. I want to know, so I'll know if to go over negative numbers. Alright, so continuing, I'll divide by the coefficient of the variable on both sides. I'll divide by 9 on both sides. 9x over 9 is minus 35 over 9. This will always cancel with this to leave me with the variable alone is equal to minus 35 over 9. And this here, I can leave it like this. I can change it to a mixed number if I want, but more than likely, I have no problem if we leave it like this. Unless the decimal is an exact number, don't put it as a decimal. Because if I work out what this is, just give me a second, just give me a calculator. If we work out what this is here, minus 35 divided by 9, we get this. Now this number actually goes further on in the calculator, but the calculator cannot express so much digits. So the calculator will give it a little approximation in the end. Right, so minus 35 over 9 is this as a decimal, which is not exact. If the number was a half, if x was a half, by all means you could put x to be 0.5. Alright, so I've seen a couple people are good and a couple people are not. So we could take a little sidetrack and focus on this thing called negative numbers. So let me deal up with some negative numbers here, right? Now, my negative numbers, it have some laws. right, that governs numbers in general. Let me do put it heading as negative. Let's put it as directed numbers. Now a directed number is just a number in a particular direction. We know that how to the right, if I have a number line, this way is positive and this way is negative. Now the concept I want to show you all here, the screen is small. Well, I can't do nothing for that. My screen big enough on my side, so that will be on your side. If you're on your phone, then it will be small. What I was saying, boy, right? We have laws that governs combinations of signs, and everybody know it. A plus and a plus is equal to a plus. A minus and a minus is equal to a minus. Sorry, a plus. A plus and a minus is equal to a minus. And a minus and a plus is equal to a minus. Now these four laws here, they are used in three instances. Three simple instances. We use these laws when we are 1. Multiplying, 2. Dividing, or 3. When the signs appear next to each other. Those are the three instances in where we will use these laws. An easy way to remember the laws: if the signs are the same, it's positive. If the signs are different, it's negative. Very, very simple concept to remember. So let me see what we can do here. If I have, before I do that, right, let me learn how to add up some of these numbers, right, before we go into the using the laws properly. Anybody else have any problem with it? The screen is small, because on my end, it's not. Right, let me just give a quick check on YouTube itself and see how the screen is looking for all you. Nah, man. I seen everything properly here. Right, I seen everything properly. Alright. No. Now, the concept I want a little build this on, right? I want a little build the concept on money. Everybody like money. Everybody like a little dollar sign something, right? Think about when I adding and subtracting money. Think about it as taking out and putting money into a bank. Obviously, if this is my bank, in my bank here, whenever I put in money into the bank, well, brother man, that is positive. If I'm taking money out of the bank, that could be negative. All right, talking about how we cash moving. If we have money in the bank, if we have money in the bank, then that's a positive. And if we owe the bank money, that's a negative. All right? All right. Let me see what we can do. I'll do the first example and then we go try and follow suit together, right? Let me say I have to calculate the sum of a series of numbers. And let me say it's 10 plus 2 minus 3 minus 4 plus 6 minus 11 plus 1 is equal to. It have plenty numbers to deal with here. I mean, one thing I can do, I can just come on my calculator, slap it in my calculator, and get the answer. But I want to show you how to do it without using a calculator, of course. So let me go. The first thing I want to check, how much money I'm starting with. Well, I seen I'm starting with a $10 there. I started with a positive $10. That means that I have money in the bank. So that $10 in the beginning means I have money in the bank, and I'm going to see what transaction is going to take place after that. So follow with me. I have $10 in the bank, I put in $2. That means I have $12 in the bank now. I have $12 in the bank, I take out $3, that means I have $9 in the bank. Then I take out $4, that means I have $5 in the bank. Then I put in $6, that means I have $11 in the bank. Then I take out $11, that means I have no money in the bank. And then I put in $1, that means I have $1 in the bank. So this is equal to 1. Given that I have money in the bank, it's positive. Let's do our next example. Minus 5 plus 3 minus 10 plus 4 plus 2 minus 9 is equal to. Let me check out this one now. Now I start in the question by owing the bank a $5. So I owe in the bank $5. So I'm going to put in a $3 in the bank. I still owe in the bank, but I owe in the bank $2. Then I'm going to take out $10 from the bank. Now I owe in the bank $12. So I go now and I put in a $4 in the bank. So I owe in the bank $8. I put in a $2 in the bank. I owe in the bank $6. And then I'm gonna take out $9. So now I owe in the bank $15. Given that I owe in the bank, this is negative 15. So I'm gonna go back up here and I'm gonna use the same concept for this set of numbers here. Alright, tell me if you all get any gist of it in the comments while I work out this one here, right? So I'm starting my question by owing the bank money. I owe in the bank $5. Then I take out $2. That means I owe in the bank $7. Then I take out $28. That means I owe in the bank $35. Right, so that's how we get negative 35 because I owe in the bank $35. Oh, Jesus. Let me do our next one. Right, so tell me if I get the gist of it so far, right? 14 minus 3 plus 10 plus 2 minus 20 plus 4 plus 1 minus 7 is equal to. Let me check and see what this is equal to. Oops. Right. I'm starting off the bank with $14 in the bank. And then everything afterwards going to be my transactions in and out of the bank. I have $14. I take out $3. That means I have $11. I have $11 and then I put in $10. That means I have $21. I put in $2. I have $23. I take out 20. That means I have $3. Then I put in 4. I have 7. I put in 1. I have 8. And then I take out 7. That means I end up with $1 in the bank. So I will pause for 2 minutes and I want some feedback on if you all understand this concept of adding and subtracting numbers. It's taking 2 minutes to do that. So I'm waiting. All right, good. I've seen a lot of yeses in the chat. Very good. All right, so this is just adding and subtracting them. So let me learn how to use the laws now, right? I'm gonna use the laws. Now, whenever we are adding and subtracting numbers, I want everybody to do this for me. Shucks, I'm gonna share back my screen, sorry. Whenever we are adding, subtracting, numbers, we want one operation, separating the numbers. Very, very important note. So for example, if I have 21 plus negative 3 minus negative 2 plus 1 minus 30 plus negative 5. I just making up. I have a big problem here. My big problem is in between numbers, I have more than one operation. I want to have one operation alone. Now, I have 4 operations in mathematics: multiplication, division, addition, and subtraction. So it's either I have a multiplication between 2 numbers, a division alone, a subtraction alone, or an addition alone. I don't want a combination of 2. Luckily, we have some laws we can follow to fix this problem. These are the laws I'm going to use. Now, if you notice here, the signs appear directly after each other. So I'm allowed to use my laws. These are my 4 laws for my operations. So let me go and use the laws here. Remember, in the back of our head, if the signs are the same, it's a positive. If the signs are different, it's a negative. So let's see what we can do here. So I have 21. The signs are different, so it's a negative. The signs are the same, so it's a positive. Plus 1 minus 30. The signs are different, so this is negative. Now I'm in a better place. And a better place to go and actually work out what the answer is. So the same thing we was doing before. Money in a bank. Money moving in and out of a bank. So let me see. I started with $21 in the bank. And then I take out a $3. So that means I have $18 in the bank. I put in 2, I mean I 20. Then I put in a 1, I 21. Then I take out a 3, I end up with 18 again. And then I take out, oh, sorry, not 3, like 30. My bad. 30 minus 5. Alright, so we starting. $21 in the bank. I take out $3. I have $18. I put in 2, I have $20. I put in 1, I have $21. And then I take out $30 from the bank. So now I'm owing the bank $9. I owe in the bank 9 and I take out the next 5. That means I owe in the bank $14 now. Alright, so this one is going to be a little waiting period for us to gauge how you're going. But what you could do, you could pause the video, and this is what we're going to work out how we're doing this in the future to get a little response from money, right? I'm going to write down a question here, and I want you to try it. Try it quickly, and tell me if I get correct. Alright? So we have 2 plus 3 minus 11 plus negative 10 minus minus 4 plus negative 5. Negative, you put negative 9. Alright? So take 2 minutes, work this out, I waiting. Alright, I was some answers in the chat. Alright, if anybody have any questions in the meantime, I could just be talking, I go be rambling. Right, I'll go down Ramble just to kill the time. Right, if you're watching this video after the live, then just skip forward to the solutions now. Don't forget to just subscribe. Right, it will help me out plenty if you subscribe. Right, leave a like or something and comment. It does help with the YouTube algorithm. Alright, yeah, calculate the sum of this here. Like, give me what the answer going on be. Right, don't use your calculators. Alright, yes, we have the luxury of using the calculators, but do you have a little mental maths now? Mental maths real important. Real important. Right? So subscribe, hit the like. Remember, I'm waiting for the answers in the chat, right? So it have about a 20-second delay from my voice reaching earlier. Alright, so let me just cater for that now. Alright, so I guess it only started already, so I'm gonna do the solution state now. So this could be 2 plus 3 minus 11. I bounce up a problem. Two operations between numbers. The signs are different, so I'll go in and I forget to show the screen again, sorry. Start over. 2 plus 3 minus 11. I bounce up a problem here. The signs are different, so that's minus 10. I bounce up a problem here. The signs are the same, so that's plus 4. I bounce up a problem here. The signs are different, so that's minus 9. So I can go ahead and work it out now. I start with a $2. I put in $3, so I have $5. Then I take out 11. That means I owe in the bank 6. Then I take out an next 10. That means I owe in the bank 16. I owe in the bank 16 and I put in 4. That means I now owe in the bank $12. And then I take out 9, and that means I owe in the bank 21 bucks. Right, so 21 buckaroos I owe back. Right, very easy concept, yeah? And we could use this for addition and subtraction of any amount of numbers. Any amount of numbers. Alright, now multiplication and division, really cutting. Really cutting. Minus 2 multiplied by 3. I'm going to use the laws, the 4 laws. Well, I'm multiplying two numbers and the signs are different because this is actually a positive 3 here. Well, a minus and a plus is a minus, so I minus 6. Minus 4 multiplied by minus 5. The signs are the same, so it will be positive. So this is positive 20. 11 by 2. Signs are the same, so it is positive 22. Next one. 14 by 3 minus 14 by minus 3, sorry. The signs are different, so I'll get a negative answer. 4 3 are 12, 1 3 is 3, and 1 is minus 42. The same thing with division. If I have 10 divided by negative 5, the signs are different, so I'll get a negative sign here, and that's minus 2. If I have minus 10 over 2, well, again, the signs are different, so I'll be minus 5. Minus 6 over minus 3. The signs are the same, so that's positive. I'll get positive 2. Now, one thing I want to show you all for a fraction, and this is important. For negative fractions, if I have negative 2 over 5, right? Negative 2 over 5. It doesn't matter where the negative sign goes. this could be written as 2 over negative 5, or it could be written as minus 2/5. So it's either the negative sign goes on the numerator, it goes on the denominator, or it goes in front of the entire fraction. It does not matter where the negative sign goes. Alright? Traditionally, all the negative signs is go on top. Alright? And you'll find that pattern will result in the easiest calculations, right? When you have to do calculations, right? When you put the negative sign on top. Alright. And that was just a quick thing on directed numbers. So everybody's supposed to be able to add and subtract directed numbers now. So we could continue with solving equations. So solve for, let me use a different variable this time now. Let me solve for y this time. Let me say we have 2y plus 4. Let me write it yet. It's dropping off. 2y plus 4 minus 6y plus 11 is equal to 3 into 4y minus 9. Well, my brackets stopping me. I'm going to expand my brackets. 2y plus 4 minus 6y plus 11 is equal to 12y take away 27. Now it's just a matter of rearranging. I'm pulling all my variables on the left. So I have 2y minus 6y. I move the minus 12, the 12y, he becomes minus 12y. The minus 27, he ain't going nowhere. I'm moving the positive 4 across, he becomes negative 4. I'm moving the positive 11 across, he becomes negative 11. And now I can simplify. Well, when you're adding variables, it's the same concept we have been doing before. Think about it as money. Alright? I start with 2 in the bank, and then I take out 6. That means I owe 4. I owe in 4, and I take out 12. I owe in 18. So I'm owing 18y. Alright? Try and finish out this question now. I had to take a call. Alright guys, work out this the left hand side there for me. I'm looking for an answer in the chat there. Work out the left hand side for me. Alright, I'm waiting. Come. Alright, well, I should be able to get that by now. So I'm doing the right hand side, this side here. Minus 27, I owe in the bank $27 from the start. then I take out 4, that means I owe in the bank 31, and then I take out 11 again, that means I owe in the bank 31, and then I borrow 11, I negative 42. So I owe in the bank $42. Well, I had to divide by the coefficient of the variable on both sides. So I'm dividing by minus 18 on both sides. Minus 18y over minus 18 is minus 42 over minus 18. U cancels with U all the time, leaving my y alone. A minus and a minus will be a plus. Sorry, will be a plus. 42 over 18. If you're comfortable simplifying it, by all means go ahead and simplify it. Right? 42 divided by 18. Let me see if we get a nice decimal point. We didn't get a nice decimal point, but I know 2.333 is 2 1/3. This is 2 1/3. Again, if you're not comfortable simplifying the fraction, by all means you could leave it like that until we get comfortable simplifying a fraction. Right? What is that? 40 minutes? I think 40 minutes is fair to find for these things we did this morning. So what I want you guys to do is to go over these things, write it down, and try some examples on your own. Right? Make up some examples on your own if you want to. Please join the Google Classroom. Let me put the link for the Google Classroom in the chat. Alright, let me know if anybody have any questions so far. Alright, so I'm going to put the link for the Google Classroom in the chat. Alright, so the question is, if it have a recurring decimal, if you put the recurring sign, will it be correct? It will be correct, right? The recurring sign, it kind of outdated. We just approximate it. So my advice to you guys, a decimal that goes on forever, we call that an irrational number. It's irrational. For any irrational numbers, express it as a fraction, because the fraction is the most accurate form of that number. All right? For example, a half, it's equal to 0.5. Both of those numbers, I can write the exact value for them. I can write 1 over 2 and I can write 0.5. But 1/3, however, the only way I can accurately write it perfectly is 1 over 3. If I go to write a decimal form, I will run out of pen and paper. I'll put 0.3 going down the road. So there's no accurate, no perfect way to represent an irrational number as a decimal. Okay, so leave it as a fraction if that is the case. Please join the Google Classroom. A lot of stuff is communicated on the Google Classroom. It's the means for all to reach me if I am not there, because you all have the ability to post something in the classroom. And yeah, that is it. So I hope this class was educational for everybody. I hope I learned something new. I intend on taking you guys straight to CXC to get ones. Alright, results come out just now, and I was very, very pleased with my results from my students. Okay, nobody failed. Nobody even got 3. So I want all to be in that same bracket. Do not doubt yourself. Right, you will have the ability. If you want it, you will get it. Alright, I here to guide everyone. So please communicate on the Google Classroom as much as you all can. And I will see everybody next week, Saturday. Same place, same time. Might be async, might be sync. I don't know as yet. Alright, so with that being said, I hope everyone has a wonderful day today. Be safe. Don't forget, subscribe, like, leave a comment under the video, and I will see everybody next week. Laters.